All right, guys. So if you are just coming after watching my video of the basics of the ellipses and you're still confused, my hope is that this video will fix it. I just wanted to jump straight into an example. It makes it a little bit easier. In this example, not only are we going to look at the components of everything, but we're going to go ahead and graph an ellipse as well. And I think it's going to make everything a little bit more structured and easy for people to understand. So with that being said, let's jump straight into our first example. Now, in this problem, they want us to find the center, vertices, co-vertices, major axis length, minor axis length, foci. Awesome. Whatever. So we're also going to graph this. And in doing this, I'm hoping that it's going to make a little bit more sense for us moving forward. Now, first thing that I want to do is I want to look at my function and I want to determine what denominator is the biggest. Clearly, 100 is the biggest denominator. What that means in my head is that my ellipse is going to be opening up longwise up and down. All right. Now that I've kind of got that in my head, that helps me a little bit in regards to a few different things. First thing I want to do is I want to find my center. Well, my center is at 4, -2. Again, I'm pulling out the -4 changes to a 4. The +2 changes to a -2 when I look at it in terms of my center. So my center is going to be at 4, -2. Well, that's not too terrible. And then I want to find my vertices. Well, it's a little bit easier for me if I find my major axis and my minor axis first. So my major axis, if I recall, is the square root of a squared. I'm going to take that value of a and I'm going to multiply that times 2. So I have the square root of 100, which gives me 10. 2 times 10 gives me 20. So that's the length of my minor axis. Now, the reason that's really helpful to me is because the value of a, which actually the value of a is the length from my center to one of my vertices. Well, since this particular ellipse is opening up and down, if I move a distance of 10 up, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I go 10 down, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That, I mean, I know it's not drawn to scale, so that's okay. But we're going to wind up with these vertices in these locations. Well, that's easy for me to find graphically. Well, now, since I'm moving up and down, that's going to change the component of my y value in the center. 4 will stay the same, and then I will do -2 plus 10, and I will do -2 minus 10. That will give me my vertices of 4, 8, and 4, -12. Easy. Next, I want to find my minor axis. Well, my minor axis is going to be the square root of b squared, which gives me b, and then we're going to do 2 times b. So the square root of 16 gives me 4. 2 times 4 gives me 8. So there's the length of my minor axis. But if I take the value of b and I move that direction, that amount left and that amount right, I will get my co-vertices. So starting in my center, if I move 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left, I now have my co-vertices. Well, again, since x is changing now, I'm going to have 4 plus 4, comma, and -2 will stay the same. And then we'll have 4 minus 4, and negative 2 will stay the same. Well, that gives me 8 comma negative 2 and 0 negative 2. And again, I know this, and I know this because my larger denominator was underneath y. Since my larger denominator was underneath y, in my vertices, it'll be my y value that changes. Since my smaller denominator was underneath x, in my co-vertices, my x value will change. So now, I've already found my center, my vertices, my co-vertices, my major axis length, my minor axis length. All I have to do at this point is find my foci. I'm going to do that by taking the square root of my larger denominator minus my smaller denominator. That's going to give me 84. And I know the square root of 84 is going to be around 9 point, I'm guessing 2, maybe. So with that being said, and now I have to check myself, 84 square root is 9.2 if we round. How awesome. So since we are opening up longwise along the y-axis, this means that I am going to take, again, my center, and I'm going to have 4 plus, negative 2 plus 9.2, and then we're going to have 4 comma negative 2 minus 9.2. So I will have a foci point at 4, 7.2, and 4 comma negative 11.2. And so in looking at this, this is nice because all I have to do is move that distance right here up and down from my center, and we have our foci points. So if I move 9.2-ish, it's going to place me about right here. If I move 9.2-ish down, I'll be right there. And then at this point, I don't know if this is going to be a pretty ellipse or not, I can graph my ellipse. Oops. Around those points, and hopefully it looks a little bit better than mine. But that is what our ellipse is going to be. So I think, hopefully, being able to look at this problem through this example, I think and I hope it makes a little bit more sense. I'm going to make another example so that you can have 3 videos that kind of go over the graphing and the pulling out of different pieces of our ellipse, just so we can have that mastery. I really hope that this makes sense. I know it's difficult, but again, it all starts with, where is my greater denominator? How does that make my ellipse open up? I always say open up, but how does that make my ellipse shaped? Is it longwise up and down, or is it longwise left and right? Then I can use that logic to find my vertices and co-vertices, major axis, minor axis. So guys, I really hope this helps. Please message me if you need anything. Thanks for checking out this video. I'll see you next time.